Hello everyone, Runa here, and welcome to the long-awaited Password Mutilator EX tutorial. I thought since July 12th marks the anniversary for the module's release, I thought why not make a tutorial for the 3rd anniversary. The goal of this module is to input a giant code at the very end of the module after figuring out what the solution for every stage is. Every stage that the module generates. Initially, you are in the pre-stage phase and need to get to the stage phase. Now, how do you do that? How do you get to the stage phase? Well, there's two cases. If the unicorn rule for the module password generator applies, which if you don't know, only applies if there is a Bamboozled Again, UltraStores, or an ultimate cycle on the bomb. In this case, it doesn't appear on it. You would submit the code apostrophe delta echo alpha delta apostrophe. Now, we don't have that, so what do we do then? Then we take the serial number and convert every digit to its alphabetical position using A0 Z25. Keep in mind, 0 indexed. 3, so we're looking at the fourth letter of the alphabet, delta. 3 again, delta. But now you notice that I pressed delta twice. Why is it saying that I just inputted one character? Well, that's because the way the module requires you to input all of the letters in the pre-stage phase in lowercase. But all of these letters are uppercase. The way you input a lowercase letter is by double tapping it. This is because otherwise you would have way too many keys on this keypad. The manual does show a giant table on page 5 of what the conversions are. Here it says that using an uppercase letter, tapping it twice, will instead input the lowercase letter. Inputting 1 twice would input an exclamation mark. Inputting A twice would result in an apostrophe. That's how you submit the unicorn rule, because there is no asterisk anywhere here. There is an easy way to memorize this entire giant table on page 5 of the manual. If you have a QWERTY keyboard, you can just look at your keyboard and clearly see what symbol double tapping it would result in what other symbol. If you would look on a typical QWERTY keyboard, which I have a layout here, tapping a 1 would twice would result in an exclamation mark. Tapping, let's pick another random key, an equal sign here, double tapping it results in a plus symbol. So that is how you go about memorizing this table. Now that we have our input figured out, let's actually input the serial number converted for the pre-stage phase. So 3 we figured out was delta, so double tap it, and double tap it again. 2 would be the third letter of the alphabet, so Charlie, double tap it. And Juliet and Golf, those just stay the same. And then 5 is a foxtrot, double tap foxtrot. The F1 key functions as your submit button, and the F2 key functions as your clear button. So now press F1 to proceed to the stage phase. At this point, you will see quite a few timers. In the top left, you will see a too fast number that changes every 2 minutes. Below it is going to be your raw value, which is going to be changing every single second. In the top right, it's the timer showing you in how long you have for the stage before it resets. And the bottom left, I didn't mention it before, but you have the elapsed time, the amount of time that this module has been not solved for, basically. And the bottom right you have the amount of bomb time remaining. Keep in mind, if you do end up striking, this number will immediately decrease and still count down normally. 1 second, 1 second real life is 1 second here. Doesn't matter if the bomb time is counting down faster. Now, your main goal, as mentioned here, is to submit a certain amount of characters, which the amount of characters is the amount of stages the module generated. Now, to figure out how many stages the module generated, there's an easy calculation for that. Here, it says that there's 4. In actuality, it's 5 because it's 0 indexed. But the way you figure out how many stages there are is that you take the amount of modules on the entire bomb, which don't include Mutilator itself and do not include needies. Bosses do count towards this module count. Divided by 2 and take and round it up. That is going to be the amount of stages. However, if that value is less than 5, it will generate 5 stages. So in this case, since I have basically Mutilator as the only module, it cannot generate 0 stages, so instead generates 5, because that's the lowest amount. Now, for every stage, what we will have to note down, the two fast, the increase factor, which is basically by how much is this number increasing, the elapsed time and the bomb time after we proceed to the next stage. Those are going to be the only values we need after we do a stage. Now, the thing is, this raw value display doesn't function normally. There's a few quirks with it. First off, the raw value display isn't necessarily always shown in base 10. This can be any base from 5 to 16. You'll notice this later when you'll probably see hexadecimal characters here. You'll just see a random alpha, a random Charlie, whatever. And another thing is that the increase factor for this display isn't constant either. It will differ by 1 on every increment, still staying on the same constant, which you're supposed to figure out. Obviously, it's not going to jump from 1 to 2 to 3 to 4. It's going to stay at like 2, and then pick between 2, 1, 3, and go back to 1, back to 3, then stay on 2 again, like that. Now, if the raw value is doing that, how in the world are we supposed to figure out the raw value? Well, the increase factor. It's actually much simpler than you think. So let's quickly analyze an example after this reset. In 3, 2, 1. Boom. There, see, hexadecimal characters. An alpha, a delta, a Charlie appeared. So now let's note down a few of these characters in a row. Well, of these screens. Wait for it to go back to like 1 digit or 3. There we go. We set it back. Basically, the display will never show more than 4 characters. It will always modulo by 10,000. Or is it 1,000? I believe it's 10,000. So let's note down A209. Oh, I screwed that up. A369, AAB8, B429, BB7A, C4C9, CC39, D588, DCD8. That should be enough. So, what do we do with this? We figure out what base is this number in, which we can figure out by looking at what point does this number stop growing and instead loops back around to being a small number. So let's see, the most significant digit is a Charlie, now it's a delta, and now it reset back to being a 3-digit number, which is obviously smaller. So the highest digit in this number is a delta, which signifies that we're in base 14. If you want to quickly remember what base it is, take the alphabetical position of whatever letter it is at the end, and just the alphabetical position of it is the last digit of the base number. If it's not in base 11, 12, 13, 14, or 15, or 16, then you can't really do this. So let's take our base converter, which I'm using this one, and we're going to be converting from a base, from whatever base it is in, which in this case we figured out was base 14, and we're converting it to base 10. So this first number, 17793, next number, and we do it for every single one. Okay, now we have our base 10 values. These screens decrypted to base 10. Now, the increase factor for a number is just the number afterwards subtracted from the number before. So we do this number minus this number minus this number minus this, and we'll get the increase factor. So let's quickly do that using TFC. Okay, now we have calculated the increase factor by taking the difference between two of these values. And now we notice something. Here it's 1441, here it's 1443, and here it's 1442. This is the plus minus 1 that I was talking about, where the increase factor differs by 1, but stays constant still. So for the true increase factor is 1442, because only when this is the increase factor, if you subtract 1, you get the lower end of whatever the number was increased by, and if you do plus 1, you'd get the higher value. So we figured out what our increase factor is. Increase factor equals 1442. And we do keep the base 10 value. That is what is important. If you're able to figure out the increase factor in whatever base it is in, well, you're still going to have to convert it to base 10. The next thing we need to note down is the too-fast display, which the module obviously reset because that took much more than 2 minutes. But let's take this one for example. 899, let's note down like this, 899515. And then once you would want to progress to a new stage, you would press F1 to submit, basically, and also proceed to the next stage. And these two times will pause. You will then take the seconds, the two least significant seconds digits. So here, 12, 13, 14, and whatever it pauses on, that is what you're going to note down for elapsed time and bomb time. So let's say I got elapsed time 16 and bomb time, I don't know, like 22. I'm only doing this right now so that I could give you an example of how to get a single, the answer for a single stage. Now that you have these 4 values, you can proceed to actually calculating the answer for the stage, which involves going through a few calculations mentioned in the manual. However, I have simplified it to just one, which is this one right here. Now, this is basically just take this equation, but instead of Charlie November, you input this. Instead of CT, you use this. But to make it simpler, I will note this down by hand. So we take the increase factor, 1442, plus the too fast value modulo 9. So let's take this value, modulo by 9. I do it, yeah, and we get 1. That's 41. And now we add the combined time, which combined time is just elapsed time plus bomb time, plus elapsed time plus bomb time. Now we take this, we get 1481. Now we move on to this calculation. The final value. We take this value and we add time. Time in this case is whatever value the elapsed bomb timer pauses at once you've finished reading all of the stages that are generated. It will just permanently pause once you've entered submission. So once you got that value, let's say it was 20 and now I'm at this number, you take the value, modulo 94, and add 33. And now we get a value. This is our final value that we're submitting. If you look at this giant table and find where 124 is, it corresponds to a vertical bar. That is going to be the symbol we're submitting, and if you were to look at a QWERTY keyboard, that would be the result of pressing backslash twice, because it's the secondary key for backslash. Now that we know how to do a single stage, let's do all of them. But I won't be doing them all by noting down the first stage, calculating the first stage, noting down the second stage, calculating the second stage. I'm only going to be noting down what's important, which are one display value, a second display value, the too fast, the base number, then also elapsed time and bomb time. My mind blanked out of that for a bit. Now, how can we get by you only using two different display values if we can get a case where we just get an increase factor that's one above or one below the actual increase factor? That is where we use not necessarily the difference between two adjacent ones, but it is between two displays further away. If you wanted to figure out the increase factor, but you're too slow at noting down, right? Let's say you only noted down the first value and the fourth value, right? These are two completely different values. If you were to take the difference between them, this isn't the increase factor. That's why you divide it then by the difference between these, whichever entry it is. Which the difference between these two is 3. Divided by 3. And now notice something. This is basically the increase factor, except it has a decimal point. The key is to use a gap of 5 between displays. If you note on the first display, count 5 forward, 1, 2, 3, 4, 5, and note on the 6th, you'll notice something. Minus x of the first, and divide by 5. It landed directly on the increase factor. Now, sure, it can end up being like 1442.2 or 1441.8, which is why you round it. You round it to the nearest integer. That is why we're able to get by only using two different display values. So now, let's get to noting down. 1 minute 22, plenty of time. We have, okay, let's first analyze what base number this is. So we have an alpha here appearing. So alphas. We have a Bravo appearing. Let's see, above now we'll go to Charlie, or will it reset back? It reset back. So this is base 12. And now let's note down two displays, one of them and the one 5 afterwards. So let's see. 1, 7, no. Let's do 2015 and 1, 2, 3, 4, fifth one, 2784. Let's note down the too fast value, 329994. The base is base 12. And now let's press the F1 key to go to the next stage, and these two timers will pause for a few seconds. note down only the seconds values that matter, which it would be this part of the timer and this part of the timer. So let's proceed. 9 and 38. 9 and 38. Now, well, this is interesting. I just saw a foxtrot in this. There. That automatically means that we're in base 16, because there cannot be a higher base than base 16 on this module. So let's note down 2 displays. Let's wait for it to reset because it might go over. And there. We have 142B, 1, 2, 3, 4, 5, 3, 6, 7, 7. Then 890523 for the 2 fast value. Obviously, no, it's base 16. Now let's press F1 again. 54 and 52. And now repeat this for however many stages you have. Now that we've finished the stage phase, now we're in pre-input. If you sit in this phase for 3 minutes, it will automatically progress to the input phase. The reason this exists is so that there will be a difference between the elapsed time value on the last stage that we need to calculate and also the final tangle value that we're going to use. To progress to the input phase manually, just press the F1 key. Now we're on the input phase. Now we are going to have to submit an actual password and hope that is correct. Now, here we have everything we need. All of the displays with the display that comes 5 afterwards, all the 2 fast values, the base that the number is in, the elapsed time, and the bomb time. Now, let's get to calculating. We'll begin by just calculating every individual increase factor. So, let's see. This is base 12. So, it goes up to Bravo. And let's convert the first number. You convert the second number. We get this and this. Yeah, I'll do every single one. Base 16, Charlie Delta Echo Foxtrot. Take the first number, this number, the second one, this. Base 15. Then base 9, which goes down to 8 as the highest possible digit that can appear. Okay, now that that's done, let's figure out the difference between these and then divide it by 5, because that's the difference we used. To make it easier to understand, I'll do this. We took the first display and then the 1, 5 afterwards. So in that case, it's just going to be this. There you go. Then we take all of these results and divide them by 5. These are our increase factors once we round them up. Well, round them to the nearest integer. So the increase factor for the first stage is 218. For the second stage, it's 1756. Third one is 586. We round up here. Then it's 470. And then here we round up 111. That is all we need. A difference of 5 between 2 display values is enough. between a distance of 4, very luck based. But the larger the distance, the better it is, better result. Just don't forget to divide by whatever distance you're taking. So now, let's plug it into the calculations again. We have our increase factor in base 10 already, plus the too fast modulo 9. So I'm just going to do that immediately. Modulo 9, every single one. For stage 1 it's 0, then it's for stage 2 it's also 0, then it's 4, then 7, then 1. Then we add the elapsed time and bomb time, which is this, and then add this. And then we take this value and then add it with our time, which on the module, it currently displays 26 minutes, 18 seconds. So how much is that in real time? 26 minutes plus 18 seconds. We don't module this by 60 though. 1578. We add 1578 to all of it. Then modulo this right here by 94 and add 33. We take each result and we get our values: 90, 89, 85, 65, and 76. Let's use this table, or if you have functions implemented into Notepad++, another thing you could do is just take whatever value you got, prepend them with this, and convert them into the standard HTML symbol based on its HTML numeric code, which this corresponds to an uppercase Zulu, this corresponds to an uppercase Yankee, this corresponds to uppercase uniform, this to uppercase alpha, and this to uppercase Lima. Okay, so we didn't really get much from this. We didn't get any weird symbols, but it's still something. So let's submit this into the module. Uppercase letters are submitted by only pressing the letter once. So Zulu, Yankee, Uniform, Alpha, Lima, submit. And that is a solid module. Now, I'll be doing another one because I want to get an answer that isn't this weird. And also because I want to discuss another thing. Okay, now that I've loaded up another password emulator, the pre-stage phase is now different because the unicorn rule for password generator does apply here. We have an ultimate cycle. To submit the password for the unicorn on for password generator on password emulator, we do 88 delta delta echo echo alpha alpha delta delta 88. The 2 8s correspond to an asterisk, the 2 deltas correspond to lowercase delta, 2 echoes to a lowercase echo, and so on. Now I generated with a lot more modules on the bomb, so now we have 10 stages. Remember it's 0 index here. So I generated a bomb with 20 modules, of which one of them is password emulator. So if we take the formula where the amount of modules on the bomb, excluding password emulator, we have 19, divided by 2, we have 9.5, rounded up, we have 10. The maximum between that and the lowest amount is 5. Amount of 5 is 10, obviously, so it's generating 10 stages. So I'm going to go through the process of noting down everything again, except hopefully get an outlier case. After doing another puzzle Mutilator, I got another answer, so let's see how to input all of this. I put it into groups of 2, but actually, let's make this simpler. There. This is what we're submitting. So first up, it is the symbol on top left, followed by an exclamation mark, which if you look at a QWERTY keyboard, is the secondary key for hotkey 1, so double tap it. Lowercase Sierra, so we double tap uppercase Sierra. Lowercase November, double tap November. Lowercase Foxtrot, double tap Foxtrot. Asterisk, which we already discussed, was double tap 8. Uppercase Papa, uppercase Golf. Lowercase Oscar, so double tap Oscar. And lowercase Yankee, double tap Yankee. Submit. Now, for the finale, I'll try my best to find another case that I want to discuss. Oh my god. Okay, this is the case that I wanted to cover, and I spent probably around 80 stages of Password Mutilator just doing this. Okay, so we have our answer string. Let's try and input this. Let's have it into groups of 3 to be able to easier to read. We have lowercase kilo, double tap kilo, lowercase Juliet, double tap the Juliet, semicolon, single tap that. Now I have a regular colon, double tap that. Uppercase India, single tap, plus symbol, double tap the equal sign. Lowercase kilo, then the 5, then a Romeo, then a Sierra. Now, you would think this is the code. However,
Beep, boop.
It's wrong. Now, I could check the log file, however, I'm confident that I have this right, but the reason why you could get a case like this, and what case this specifically is that right here lies a bit of a problem. To input a colon, you have to do 2 inputs of a semicolon. So the inputs here go kilo, kilo, Juliet, Juliet, colon, 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 and now you see the problem. This we can ignore. The problem is that we input colon 3 times. So what actually gets submitted is a colon followed by a semicolon. Because it recognizes these 2 inputs, does a colon, and then a single one. How to counteract this? There's no method. Write whatever was before, so I wrote Kilo Juliet. Now, write the colon. Skip the semicolon entirely. Write the colon. So double tap the semicolon. And now you can use these arrows. Press the left one. Now what we've entered is Kilo, Juliet, and colon. So now we moved left by 1. And now we input colon. There's a single one. And now we move right again. So we move left, colon, now move right. And like that, we can bypass this. And now input the rest as usual. So India, this, kilo, kilo, 5, Romeo, Sierra. Should be good? Yeah. That is the outlier case that I was looking for so long. Now, another thing that I didn't get to appear, sadly, is this. If a current stage's final value is equal to the previous stage's, add 1 to the final value, or subtract 1 if it would go over 126. So basically, if I had two final values where one of them ended up being, let's Control-C this. One of them ended up with like a final value of 125, and another one ended up with 125. You're not allowed to input this. An input like this never will appear for two of the same symbol, one after the other. So in this case, you would add 1, making it 126, and turning it into a different symbol. Or in the case where it's 126, 126, in that case it becomes 126, 125. So yeah, that is all I wanted to cover with Mutilator. All of these notes here that I have, I'll leave it up like this right now, scrolling slowly, for anyone who wants to read it, because this is the short form that I've done. I will also leave it in the description. Now, that is pretty much it for this module. Thank you all for watching this tutorial. My brain hurts. And I will see you all in my next tutorial.